we have a problem here to solve. So we are told that a solid steel shaft AB, as shown in figure 511, is to be used to transmit 5 horsepower from the motor M to which it is attached. If the shaft rotates at an angular velocity of 175 revolutions per minute and the steel has an allowable shear stress of 14.5 kc, determine the required diameter of the shaft to the nearest 1/8 inches. So this question is all about a shaft design, you could see, because we need to determine the diameter of the shaft to the nearest 1/8 inches. So these are the following steps to solve the problem. Step 1. Read the problem carefully. And step 2, check which is the main formula needed to solve the problem. Because it's a shaft design, because we need to determine the diameter to the nearest 1/8 inches, so it's a shaft design. So what is the diameter for a shaft design? In class I gave you this formula. The polar moment over the radius equal to what? The torque over the allowable shear stress. So this is the main formula used in shaft design. This is the polar moment. This is the radius, which I said is a radius from a given distance. This is the torque, which in this case is still a moment, which we spoke in class, and this is the allowable shear stress. So now that we've gotten the formula, the next thing is to determine the parameters, because we know that we're gonna solve for this radius. That's what we need to solve to be able to compare with this diameter for the shaft as given. So therefore we can say that I'll start by looking at the equation, and I get the value for the polar moment, get the value for the torque, I get the value for allowable shear stress, which is given on the question. So now I go to step 3. Step 3. I need to convert the unit. Convert the unit to the correct unit. And now I'm given horsepower. I'm given 5 horsepower, but I know that I have to convert horsepower to FT pounds per second, because I need to get my diameter in inches, and I can easily convert foot pounds per second to inches. So see what I'm going to do. 1 horsepower. 1 horsepower is equal to what? Is equal to 550 ft pounds per second. And I check my angular velocity, which is given in revolution per minute. I can convert that to rad, because I can be able to get that to the rad unit, which is going to be given as such: angular velocity of 175 revolution per minute as given in the problem here. I know for sure that I need to convert this to rad per second, because I can still convert that to my unit in inches, which is quite easy. And therefore, to convert that to rad per second, I will say that 1 second, rather I will say 1 minute, I will say 1 minute equal to 60 seconds, and 1 revolution is equal to what? 2 pi rads. And therefore, step 3, which I've done, will take me to step 4. And step 4, I will solve the problem. Remember, what am I solving? I need to get the torque. How do I get the torque? I need to get the torque. The torque is not given in the problem, but I am given the power in horsepower, and therefore I can remember that power equal to torque times angular velocity. So this is power, this is torque, this is angular velocity. It therefore means that I know that the power which I have is given as in 5 horsepower. But what is 1 horsepower? 1 horsepower is equal to what? 550 ft pounds per second. And this will give me a value of 2750 ft pounds per second. Likewise, angular velocity is equal to what? 175 revolution per minute as given in the problem. And what is 1 revolution? 1 revolution is equal to what? 2 pi rad. And what is 1 minute? 1 minute is equal to what? 60 seconds. And therefore this minute and this minute will cancel, and revolution will cancel, same as horsepower and horsepower cancel. And we have angular velocity is going to be what? It's going to be 18.33 rads per second. That is the value, and therefore I can say that power equals to what? Torque times angular velocity is equal to what? The power for that is 2750 foot-pounds per second is equal to what? is equal to torque, which is what I have to solve, times what? Angular velocity, which is 18.33 rad per second, and therefore the torque is going to be 150.06 pounds times Ft, and that is the torque. Remember, from the equation of shaft design, I know that the polar moment is equal to what? C is equal to T over the allowable shear stress. And we know for sure that what is the polar moment for solid shaft? Polar moment for solid shaft, because that shaft is a solid shaft as seen in the problem. It's a solid steel shaft. So the polar moment for a solid steel shaft is equal to what? Is equal to pi over 2 times c to the power 4, and that c is a radius. It's a radius. Therefore, if I put that in that equation, I'm going to have what? I'm going to have J over C, which will become what? Which will become pi over 2 times C to the power 4 over C times C to the power 4 over C equal to what? Equal to torque over allowable shear stress. It therefore means we can say that C is equal to what? 2 times torque over pi times allowable shear stress. It therefore means if I put the value for this torque, which is 150.06 pounds times Ft, and this allowable shear stress, which we know from the equation, we have the allowable shear stress as 14.5 kc. That will become what? That will become 14.50. We'll convert that to pounds over inch square, because we must get this radius. This is the radius. We must get that to inches, and therefore multiply this times what? Times 12 inch foot. All that multiplied by what? Multiplied by 1 over 3. In fact, this formula that you see here, all of this formula is multiplied by 1 over 3. If you solve for that, if you solve for this C, you're going to have this 2 pi. You're going to have 2 times torque, 2 times torque over pi times the allowable shear stress times 1 to the power 3, if that is simplified, because this C and this will cancel, and I will have C to the power 3, and this is the value for that radius C. And therefore, if you multiply by this to the power 1 over 3, we are going to have C as 0.492 inch, and that is the C, which is the radius. So C is the radius. C is the radius. But we know that what is radius compared to the relating to diameter? Diameter is equal to what? 2 times radius, and therefore I'll multiply 2 times this value, which is 0.492 inch, and I'll have 0.8584. Therefore, G can be 7/8 inch, which is going to be close to 0.875 inch. And that is the answer. Which is equal to 0.875 inch. So that is actually the shaft diameter that motor can drive without any mechanical failure. So thank you very much for watching. Thank you.